Imagine, just for a second, a world where that absolute universal dread of airport parking is literally a thing of the past. No more driving in circles around dark concrete garages for 20 minutes, no more squeezing into impossibly tight spots, and absolutely no more of those pre-flight panic attacks, right? Well, today in our AI News Explainer, we're diving into how autonomous robotics is turning that exact dream into reality.
So what if you never had to search for a parking spot again? Honestly, it sounds totally like science fiction, doesn't it? But it's happening right now. London Gatwick has officially launched the UK's first robotic airport parking service. They've teamed up in a massive partnership with deep tech company Stanley Robotics, and this system completely 100% automates vehicle placement and retrieval. So today we're going to unpack the absolute engineering sorcery that makes this possible. We'll look at the massive infrastructure implications and, of course, explore the cutting-edge tech under the hood. Here's our roadmap for today. First, the airport parking upgrade. Then, we'll meet your robot valet. Third, the infrastructure game changer. Fourth, engineering under the hood. And finally, system constraints and limitations. Let's get right into it. All right, Section 1, the airport parking upgrade, or a stress-free start to your journey. You know how finding a parking spot before a flight is just universally hated, right? Well, Gatwick is tackling this head on. They've strategically deployed this advanced robotic service right near their south terminal. It operates entirely on an advanced booking model, and it's specifically designed to just completely remove all the friction of the traditional parking experience. The whole idea here is that your vacation should actually start at the drop-off, seamlessly getting you from your car to the check-in desk way, way faster. Moving to Section 2, meet your robot valet. Let's look at how the autonomous handover actually works. So instead of hunting for a spot, your journey follows this incredibly seamless, highly controlled flow. First off, you drive your vehicle into a private enclosed drop-off cabin and just scan your booking. Step 2, and honestly, this is a massive differentiator from traditional valet services. You keep your physical keys and simply walk away. Yep, there's absolutely no handing over your keys to a stranger. Then Step 3. Once you exit, a Stanley Robotics autonomous mobile robot slides right underneath your vehicle. It is seriously incredible to watch. It gently lifts your car by its tires. And finally, Step 4, it safely transports your car into a secure, high-density storage area, literally human-free from the second you step out of the cabin. But you know what is genuinely fascinating? How the system handles your return. When you initially book the service, you input your return flight details. The back-end system actively monitors your flight's arrival time, so it's anticipating exactly when you'll land. By the time you grab your bags and walk out of the terminal, the autonomous robots have already retrieved your car from deep storage and placed it right back into a collection cabin, just sitting there waiting for you. It is an incredibly slick, fully automated loop. On to Section 3, the infrastructure game changer, maximizing space without pouring concrete. Now, if we peel back that consumer layer, we uncover some really massive operational hacks for the airport itself. Think about it. Traditional parking is incredibly wasteful when it comes to space. We're talking wide driving lanes, huge safety margins, pedestrian walkways, bright lighting, heavy ventilation systems, the whole shebang. Robotic parking, on the other hand, operates in a tightly controlled environment. It's kind of like a giant vending machine, but for cars. There's no need for human walkways or bright lights inside. Since humans never, ever enter the storage area, vehicles can be packed together with minimal clearance. It essentially operates as dark storage, which means way, way less operational overhead. 40%. Seriously, just imagine instantly adding almost half a parking garage out of thin air, all without pouring a single drop of new concrete. By stacking those vehicles closer together and completely eliminating the need for human access lanes, Gatwick can increase their parking capacity by up to 40%, all within the exact same physical footprint. For a high-volume hub that's dealing with strict zoning limits and real land scarcity, being able to scale capacity vertically and horizontally without breaking ground on new facilities, that is an absolute game changer. Which brings us to Section 4, engineering under the hood. Let's look at the architecture powering the robots. So how on earth do they actually achieve this massive capacity boost safely? Well, the secret sauce here is deterministic control loops. If a robot is navigating a chaotic, unpredictable city street, it uses something called SLAM, simultaneous localization and mapping. And that is incredibly complex. But here, the robots are operating in a closed, highly controlled loop. They have fixed, established reference points, which allows the engineers to rely on high-frequency sensor feedback for super precise, deterministic motion planning. Basically, these robots know exactly where they are down to the millisecond. And because they shift all that brain power to the back end, you, as the customer, don't need to download some clunky app to track your car. The system meticulously does it for you. Engineers manage a vehicle's exact status using what are known as finite state machines. Simply put, the system tracks your car as it transitions through very distinct states, from drop-off right to scanning, then transport, storage, and finally retrieval. Every single vehicle in that fleet is just constantly monitored within this logical flow. Now, the safety protocols here are absolutely rigorous. We're talking redundant LiDAR, ultrasonic sensors everywhere, and immediate manual overrides that get triggered by ISO 3691-4 safety interlocks if anything looks even slightly off. And on the software side, this system ensures your booking data never duplicates through idempotent booking confirmations. That keeps the API perfectly synchronized with a real-time robot fleet with zero latency. Add in some heavy predictive maintenance pipelines that track motor temperatures and structural wear, and you ensure maximum uptime for all these robotic units. It's really brilliant engineering. Moving into our final part, Section 5, System Constraints and Limitations. Basically, what happens when the robots say no? Of course, to guarantee safe automated handling, there are some pretty strict physical constraints on the vehicles allowed into the system. The maximum weight is capped at 2.6 tons, and the height maxes out at 2.3 meters. The wheelbase can't exceed 3.3 meters, and the wheel diameter is strictly limited to 21 inches. Now, while the vast majority of standard passenger cars will fit perfectly within these limits, if your vehicle exceeds these parameters, the robots will simply pass on it. It's a hard limit. There are also a few other practical limitations to keep in mind. This system requires advanced booking to create a predictable load profile, so sorry, there are no spontaneous same-day drive-ups allowed. Also, non-standard geometries are going to fail those automated scanning checks, so if you are planning on bringing your giant wide-body truck with those huge protruding roof racks, you'll have to park the old-fashioned way. And really, even something as simple as a muddy, obstructed license plate or damaged sensors will kick the vehicle straight into a manual inspection queue. That, in turn, could definitely cause some throughput delays during peak arrival windows. But despite those few edge cases, this deployment is just a massive leap forward. As Clement Boussault, the CEO of Stanley Robotics, noted, this project addresses critical parking capacity challenges for airports preparing for significant growth. He called it a major milestone, and it really elevates this highly technical marvel into a scalable, visionary solution for expanding global aviation hubs that desperately need to optimize space without sprawling outward into their surrounding communities. Which leaves us with a really fascinating question to ponder. We've just seen how integrating AI robotics with existing infrastructure can practically magically create 40% more space in an airport. So how will deterministic robotics and AI redefine the infrastructure of our future cities? I mean, if we can solve space scarcity for cars without pouring a single new drop of concrete, what other urban bottlenecks are just waiting to be revolutionized by autonomous robots? Thank you so much for joining me for this explainer today, and I really hope this sparks some curiosity about the incredible AI systems that are operating right under our noses. See you next time.